Hello friends, I'm here with my channel Pioneer Tutorial, and now we are going to discuss about Wheatstone bridge principle. There are several problems. While seeing that, we will not be able to judge whether we are going to apply the Wheatstone bridge or not. But today I am going to use some simple steps to understand the Wheatstone bridge and how several problems can be molded towards Wheatstone bridge. I will be telling you that also. Please keep watching and like and subscribe this channel if you know and understand. If you do this, if you actually love this, then you can be able to solve any kind of problem whatever you are facing with this related topic. Okay, let's start. Now, as you can see, this is a Wheatstone bridge that we are having. Okay, and what is the principle of Wheatstone bridge actually? It is that whenever a balanced bridge is there. What do you mean by balanced bridge? Means what? The potential of this position, the potential of this, the potential of this, and the potential of this. If there are four potentials here. So actually for balancing effects, what we require? We require V1 is equals to V2 and V3 is equals to V4. So by applying this principle, whatever we are getting, that is the principle of the opposite corner resistances, the product of opposite corner resistances, the arms resistances, their product should be same. Or we can say that the ratio of the similar limb resistances has to be same. That is R1 by R2 is equals to R3 by R4. If this thing satisfies, means what? The bridge is in balanced condition and the current from the middle branch, from the galvanometer, it will not flow, means Ig will be equals to 0. And this principle, whatever I am going to tell you, this will be only valid if and only if the balanced condition is reached. Okay, so whenever this balanced condition is reached, whatever the problem is that we can easily calculate any unknown resistances present on the bridge arms. And this thing, this phenomena is actually valid for the impedances also. Means whatever connection is there, that can be resistance, inductance or capacitance, we can just convert it to equivalent impedances and the same phenomena remains true for them also. Means this is a very good technique to actually calculate the circuit. And whenever you are having, say, a problem, whenever having a problem, we can easily solve it. Let's just take an example out of it. Say you are having 5 resistances connected like this. Okay, this, everyone is having the same value. Just for simplicity we are taking it. Say this circuit is being given to you and every resistance is having 10 ohms value. Now they are asking you to calculate the equivalent resistance between these two terminals A and B. Now at a glance, whenever we are seeing it, can you be able to tell me it is a Wheatstone bridge or not? This is very much difficult to actually tell. So what are we going to do? It is of the same technique that we have discussed earlier, that we have to give some name to the points intersecting inside the circuit. That is, this point is named as C and this is as D. So if we are taking these two points as our reference, that is the output terminals, say this is my A, this is my B, and this C and D, if we take it here and here, then what is going to do? We are going to just draw the circuit accordingly in between the points only. We are not going to say where the current is going, where it is not going. We are not seeing any of them. We are just going to take the resistances out from the circuit and we have to again replace or redesign the circuit in this manner. Okay. Now we can see that between A and C, there is a resistance that is 10 ohms. So we are just drawing it here. 10 ohms. Between C and B, this is C, this is B, and between them there is a resistance 10 ohms. Between A and D, again we can see this is A, this is D, in between them there is a resistance of 10 ohms. and between D and B 10 ohms, and between C and D there is also 10 ohms. Now the question is given to be as what is the equivalent resistance. If someone doesn't know about Wheatstone bridge, what he is going to do? He is going to make this delta as a star like this. Now he is going to be solving the circuit, and it is also true, you can actually do that. But whenever you are checking the balancing phenomena here, that is the product of these two means 100 is equal to the product of these two means that is also equal to 100, means Wheatstone bridge concept is valid for this that we have discussed earlier. Means what? This resistance will not carry any of the current. The current will flow from this part. Say from this part the current will be going, and from here it will go out, and from if the second part of the current it is going towards this and it will go from here. There is nothing in this position. Means what? We can easily say that the resistance equivalency is of the upper path is 10 plus 10 for the series circuit and 10 plus 10 for the lower series circuit, but in between them there is the parallel connection. What we can get? 20 parallel 20, so that is nothing but 10 ohms. So this will be the easiest problem solving technique for this kind of circuits. If you are going to be solving this, then Wheatstone bridge is a very powerful technique. Please learn this, practice this as much as you can, then this type of problems will be very much easier for you. Thank you for watching my channel.